This is why I'm calling it Saturn's weirdest moons. Just give me 1 second, and here we go. Okay, hope you can see that. The
Yeah.
first one is this moon, Hyperion, which is most bizarre. As you can see, it's got a surface that resembles a sponge. And, Cassini flew by this close distance, about 5,000 miles away. And everybody was just amazed at what this moon actually looked like. Just a few details about Hyperion. It's 360 by 266 kilometers. Do forgive me if I slip between miles and kilometers, because I'm in that difficult age, It's designated Saturn 7. In other words, it's the seventh moon from Saturn going outwards. It's actually 1.5 million kilometers away from Saturn. Its composition is mainly water ice with a bit of rock thrown in. And it's got an incredibly low density for a moon of its size. Now, what this means is when meteoroids, if you want to call them that, bits of rock hit it, instead of causing a big impact and a huge crater and flinging material into the space, the density of Hyperion is so low that it just sort of punctures the surface and digs downwards without actually making a huge crater. So as you can see from this image, if you look down the craters, they're cylindrical rather than sort of bowl-shaped. And this is put down to the low density of the material that allows any incoming rock just to go straight in. As I said, Cassini imaged Hyperion 3 times, the first in September 2005 and the last in May 2015. But Cassini's orbit did not allow it to approach Hyperion any more regularly than that. Only 3 times it managed to fly past the moon. There's a photo from another flyby of Hyperion. The bottom of the craters is a very dark reddish material, similar to the material that we find on some of the other moons like Iapetus, and that's why the crater bottoms appear dark. Complex organics are found in this material on some of the other moons, so it's to be assumed it's virtually the same here. And speaking of Iapetus, I mean, Iapetus is a weird body. Iapetus, those of you of a certain age may remember that in the book 2001: A Space Odyssey, it actually took place at Saturn rather than Jupiter in the book. In the film, it was Jupiter, but the special effects team couldn't come up with a realistic method in those days, back in the mid-60s, of representing Saturn's rings. So they moved the location of the final act of the film to Jupiter. But in the book, it was Saturn, and Iapetus is featured in the book because Arthur C. Clarke, who wrote the book, being a man of astronomy, he knew exactly what was odd about Iapetus, and what's been known for a very long time is that Iapetus is dark on one hemisphere, very dark, and very bright on the other hemisphere. And what Cassini found when it got there, as you can see in this image, is almost all of the way around the equator, there's this ridge. It looks like 2 halves of a moon have sort of been welded together, and that's the weld line. So this is certainly extremely odd. I'll talk about the ridge in a moment. So this was a very odd moon with its bright hemisphere and its dark hemisphere. It's 1492 by 1424 kilometers, so nearly spherical. It's designated Saturn 8. It's 3,560,000 odd kilometers from Saturn. Its composition, again, is mainly water ice with some rock thrown in. And that dark material is thought to have originated from outside Iapetus, perhaps from other moons. And the dark color is thought to be due to sublimation, which is a process where a solid turns from a solid straight into gas with no liquid phase. And that material is then further darkened by the action of sunlight. And it's not quite clear yet, I don't think, although I'm sure Lou or Bernard will correct me. I don't think there's any convincing explanation yet for why only one hemisphere is that dark color and the other hemisphere is covered in ice, which is why it's so bright. So that's Iapetus, but the ridge around the equator on Iapetus is amazing. It's 15 kilometers tall, and if you compare that with Everest's 9 kilometers, so it's getting on for twice the height of Everest, that ridge you see before you. It's thought to be formed from the debris of a ring that Iapetus once had that actually collapsed onto the planet, forming this ridge around the equator. Although I don't think that's settled yet, but I think that's the leading theory, that it's the remains of a ring that collapsed onto the surface, onto the equator of Iapetus. This is an amazing image, but this image I absolutely adore, which is a close-up of that ridge. And I did feature this as one of my favorite space images when it was my turn, because this is such a beautiful, haunting image, and you can imagine exploring that amazing terrain. It's just absolutely stunning. So that's Iapetus. Now we move on to a truly weird moon of Saturn, and this is the moon Pan. Now there are two images of it here taken by Cassini from different angles. It's been called the ravioli moon because it looks like a piece of ravioli. How on earth did a moon like this form and get that again a thin ridge right around its equator? It looks like some sort of a UFO. This moon is very small compared to the others. It's only 35 by 25 kilometers. It's designated Saturn XV111, and it's 133,000 kilometers from the planet. Its composition, although it's uncertain, it hasn't been directly measured. It's presumed to be mainly water ice again, with some rock thrown in. And Pan is what we call a shepherd moon of Saturn. And a shepherd moon is one that literally confines one of Saturn's rings and keeps it as a ring so that it doesn't dissipate and spread out. And in this case, what Pan does is to keep the Encke gap, which is a gap between Saturn's rings, free of material. So it's sweeping up material from the Encke gap all the time. And it's this material that it's swept up, which is thought to fall on its surface and form this equatorial ring over time, over a long time. So it's literally, because the moon is acting as a sort of hoover, if you like, it's hoovering up this material which settles on its equator and forms this incredible ridge around it. Now, just so you know where we are, these are Saturn's rings, and you can see towards the right, there's the Encke gap. So we've got several gaps in Saturn's rings. We've got the Huygens gap. We've got the famous Cassini division, which was first seen by Galileo. We've got the Encke gap, and we've got the smaller Keeler gap. And Pan actually patrols, if you like, within the Encke gap, sweeping up any material that has entered it from the rings. And here's an image taken by Cassini of Pan actually in the Encke gap. So that's a beautiful image of that little moon actually in the middle of the Encke gap there, which I think is an amazing image. We move on now to our last moon of this evening, Atlas. Now, Atlas is another moon that similarly has a ridge around it. This, I think, is an amazing image because basically you're seeing a mountain on the top of the moon with this weird ridge around its equator. And Atlas is, getting on for the same size as Pan, 40 by 35 by 18.6 kilometers. It's designated Saturn XV. It's 137,000 kilometers from the planet. Again, it's thought mainly to be water ice. And because for a long time, Atlas was thought to be shepherding the A ring to make it keep its shape, if you like, it's now thought that it isn't actually a shepherd ring of the A ring at all. And latest information indicates that the ring is kept in its within its limits, if you like, by the action of 3 other moons: Prometheus, Janus, and another one I can't remember. So Atlas is not actually a shepherd moon, but in that case, how did it get that? If it's not picking up material like a shepherd moon does, how does it actually get that ridge around its equator? Well, something that Cassini discovered in 2004 was this ring of material that is actually within the orbit of Atlas, and this is the material that Atlas has swept up and has formed that ridge around its equator, and that answers the question. So there you are. So they're the tonight's moons, the weirdest moons of Saturn, and I think you'll agree in terms of what they look like. They're certainly extremely weird moons. So there you are.
Yeah, they certainly are. Yeah, and was there ever when you mentioned the last group, the 3? You said, what was it? You said Prometheus, Epimetheus. Was there ever one Pandora?
Could be Pandora. Yes, it could be. Have to look that up.
Yeah, I could be wrong there. They're just all those. But you were talking about Hyperion. Of course, Hyperion, as well as looking strange, it's got a very strange behaviour as well. It's tumbling totally out of control.
Yes, it is.
There's nothing unified.
No.
Yeah, nothing unified about its the way it rotates, or it's literally tumbling, and you can't predict anything. Yeah. It keeps changing all the time. Yeah, and as you said, it's a very strange sponge-looking looking thing. But also, I mean, as we know, Saturn's got loads of moons or moonlets, or and of course, some of the naming's quite novel. I'll just read you this. Saturn has 2 orbital groups of prograde irregular satellites. The individuals in one are given Inuit names such as Sironwak, and in other Gaelic names as Alborix. Each group could be remains of a larger moon destroyed by collision. Apart from Phoebe, Saturn's retrograde irregular satellites have Norse names, and include groupings that could each represent fragments of the same captured asteroid. So, yeah, they've got so many, with Jupiter and Saturn having so many moons, they're really having to spread the net to find names for all these things. For them. And of course, most of them are found by that group of people sat on the Hawaiian mountain, and all they do all day is look for moons, and they're quite successful at it. So, as we said, they need to get a proper job.
Nice work if you can get it, Daz. That's all I want to say.
Yeah, too right.
Bernard or Lou, do you want to add anything about any of those moons?
I'll let Lou start.
Well, the only thing I was thinking is that this chaotic tumbling of Hyperion seems to be a product of its both its irregular shape and its 4-3 resonance with Titan. So these 2 qualities act together to give it this kind of strange rotation movement.
Yeah, thanks.
With regards to Iapetus, you were wondering about the difference in one side is brighter and the other side is darker. Isn't that related to the trailing side and the leading side, where the leading side just picks up all the dust and everything as it goes through Saturn, as it orbits around Saturn?
I believe that's correct, Bernard.
Right. So,
Steve's just popped in the chat. Steve's just popped in the chat probably a theory about that. So if you look at the curved horizon of Iapetus on one side of the ridge and trace it across, it doesn't seem to match the circle on the other side of the ridge, suggesting a compression feature. Maybe.
Interesting.
So you have 2 things pushing together. So
if that's the case, if it is a case of the leading edge and the trailing edge, or the trailing side, is Iapetus tidally locked?
You're the one who did this presentation. You should know. I forgot.
I've forgotten as well. Yeah.
Too many moons around Saturn.
Most moons are. but
Yeah,
I don't know
true.
about
Yeah.
Iapetus in particular.
Yeah, I'll have to ask ChatGPT about that. Okay, so there we are. So those are the moons of the week.